Welcome to new session. So in your last previous classes, we discussed about how to use hybridization, what is actual meaning of hybridization, how hybridization is going to help to determine the accurate structure of a given molecule, and what is the use of hybridization we discussed. And even in your last class also, we discussed some selective applications on a concept of variable hybridization related molecules. Okay, that is called du nothing but degree of unsaturation. So today we will see how to make a use of calculation sigma as well as pi bond in a given molecule. Okay, right, see, so simple formula I will give to that helpful for calculation of sigma and pi. How to calculate sigma and pi bonds in a given molecule. So one of the easiest method, from this you are going to expect some questions in your NEET examination, and even this is also helpful for inorganic as well as organic. Okay, so first we will see how to calculate sigma bonds for a given hydrocarbon. Okay, so first see, I am going to take alkane. You know alkane? What is the general formula of alkane? General formula of alkane is CN. Yesterday I given. Are you listening that class? CnH2n plus 2. This is the general formula of alkane, right? So alkane is a hydrocarbon which carry only carbon and hydrogen. Suppose if I substitute n is equal to 1 nothing but 1 carbon. If I substitute here 1, and if you substitute 1 here, 2 into 1, 2 plus 2, total 4. So CH4. Suppose if I substitute 2 here, then what is your formula? So can I write like this, C2, then I say H6. Is it right? 2 into 2, 4 plus 2, like that. Then go through C3, and what is your answer? C3H8, then C4H10. Like that you are keep on getting a hydrocarbons like that. They are called homologous series. They are called homologous series. And what are homologous series? Generally, molecules having same general formula but differ in their CH2 unit. See the difference between these two. One carbon, 2 hydrogens are differ, and here also one carbon, 2 hydrogens are differ. So they are called, what are they? Homologous series. And every individual unit is known as homolog. Okay. Suppose if I take any alkane, remember, number of carbons multiplied by 3, that is plus 1. This is a formula to calculate number of sigma bonds. How to calculate number of sigma bonds? Number of carbons in a given hydrocarbon multiplied by 3, then add plus 1. Then you will get total number of hydrocarbons in a alkane. How can you identify it is alkane or not? How can you identify? See, by watching this, can you say whether it is alkane or not? Yes, you can. Because if you know this formula, one can easily confirm that whether it is a alkane or not. Clear? See, alkane nothing but they carry only sigma bonds, but there is no pi bond. There is no double bond, there is no triple bond. Every carbon gets surrounded by only sigma bonds. That is called an alkane. So one example I will give. Just see this. I am writing CH4. Carbon gets surrounded by how many? See this. This is carbon CH4. How many hydrogens are present around carbon? 4 or not? Can I write like this? Now see, is it a sigma bond? The bond present between carbon and hydrogen, carbon and carbon, all are called sigma bond. Now it is a sigma, here also sigma, sigma, sigma. How many sigmas? Total 4 sigmas or not? Now you will get 4 sigmas, that is a formula. Now substitute in this formula. How many carbons are present in this one? In this molecule, how many carbons are there? 1. 1 into 3, 3. 3 plus 1, 4. You will get this answer or not? Suppose if I write this molecule, CH3 attaches to one more CH3. What is this? Ethane. This is ethane or not? C2H6. C2H6. This and this both are same. Here, this molecule I am writing in a convenient way so that you can understand clearly. Carbon, hydrogen, like this. If I say this molecule, if you see how many sigma bonds are present, if I written structure clearly, if I write structure clearly, can you say number of sigma bonds are 7 or not? Here this is 1, 2, 3, 4, 5, 6 and what is this? 7. Total how many sigma bonds? 7. So by watching the structure of a given alkane, I can say they carry 7 sigma. Then how can you use this formula? See, suppose here number of carbons are how many? 2. Substitute in this formula. 2 into 3 how much? 6. 6 plus 1, 7. Matching or not? So you can use this formula directly. Otherwise, you need to know about the complete information about structure. Okay? Once if you enter into the concepts, there it will be clear that what will be the actual structure of a molecule and what will be the property of that molecule, how to identify a structure. Okay? Next, this is ethane. Now I am writing a propane. So what it means? Propane, how many carbons are present? 3 carbons. Right? Is it propane? Now, this carbon gets surrounded by how many hydrogens? This carbon surrounded by like this. So what is the valency of carbon? Carbon valence is 4. Every carbon surrounded by 4 bonds. And here also how many are present? 4 bonds. Here also 4. How many sigmas are present here? How many sigmas? Sigma, sigma, sigma. Like this we need to write. Just count and say. How many sigmas are present? So here this is 3 plus 3. 6, 7, 8, 9, 10. Now if you substitute in this formula. 3 into 3. 9. 9 plus 1, 10. Right or not? Once if you know structure clearly, otherwise if you know the formula, one can easily identify number of sigmas present in a given molecule. Is it clear? Now just listen one more. I will give second molecule that is belongs to alkene. You need to remember this formula for calculating number of sigma bonds in a given molecule. Alkene, what it means? So what is the meaning of alkene? Alkene nothing but carbon-carbon double bond. Alkane nothing but, what is alkane? Which carry only sigma bond. If carbon-carbon carries single bond, that is called alkane. If carbon-carbon carry double bond, that is called alkane. See, between two carbons, minimum, between two carbons in a molecule, minimum if at least one double bond is present, that molecule is said to be alkene. Minimum one double bond is required. So see here how many carbons are there? 3 carbons. Out of these 3 carbons, any carbon having double bond? Out of these 3, any carbon having double bond? No. See, all are single bonds or not? Anywhere will you find any double bond here? No. All are single bonds. On that time that is alkane. It should be hydrocarbon. It should not be ring. It should be open chain. Is it open chain or ring? All are open chain. There is no ring formation. If it is a open chain, if there is no double bond, if it is a carbohydrate or hydrocarbon, okay, hydrocarbon, alkane nothing but a hydrocarbon. What it means? Hydrocarbon means the molecule which carry only carbon and hydrogen. See, in this molecule, other than carbon and hydrogen, any other element is present? No. So it is a hydrocarbon. So what is the difference between alkane and alkene? Alkane is the molecule which carry only sigma bonds. Between two carbons in total molecule, all carry sigma bonds. There is no double bond. In this minimum, one double bond is present between two carbons in anywhere in a system. At least one double bond. Okay. So here see, this is carbon-carbon double bond consisting species. Alkane. What is the formula? What is the formula for alkane? CnH2n plus 2. Now here formula is CnH2n. Say I remove this 2 or not? Here plus 2 is there. I remove the 2. Then what is the formula? CnH2n. Now see this. If I substitute in 1 in this one. See, in order to write double bond, minimum how many carbons are required? Minimum 2 carbons. So if you want to create any alkene, we need to substitute 2 here, minimum 2. So with 1 carbon, can you write double bond? With the help of 1 carbon, is it possible to write double bond? No, it is impossible. If you want to write double bond, definitely how many carbons are required? Minimum 2. Is it clear? So that's why I am substituting 2 here. If I substitute 2 here, can you write the formula? If I substitute 2 here, can you write the formula? This is called general formula. Remember. Now what is this? If I substitute 2 here in this one, what is that? C2, say the one, H4. Can I say? Right or not? So what is the integer I substituted in this one? 2. Is it right or not? Now I am substituting 3 here. Then what is the formula? C3H6. If I substitute 4 here, C4H8. Are you able to understand or not? Is it clear? See the simple logic. How many carbons are there? 2. Double that number, that becomes hydrogen. How many carbons are there? Double that number, that becomes hydrogen. So it is a way to identify alkene. If number of hydrogens are double, then carbon, that becomes alkene. Simple. Suppose if 10 carbons are there, how many hydrogens? See, I want to create one alkene with 5 carbons. How many hydrogens are present? Guess. 10. I want to create an alkene with 6 carbon. What is the formula? C6H12. Then C7H14. C18H16. Then C9H18. Suppose if C10 is there, then what about next? C20. These all are called alkene. Very easy to identify. See the difference. C2H4 and what is this? C2H6. Double the carbon number, add plus 2. That is alkane. Double carbon number, add plus 2. If they give hydrogen, double carbon number, how much? 4. Add plus 2, 6. Double carbon number. Double the carbon number, 6. Add plus 2, 8. Double carbon number, add plus 2, 10. So this is a way to identify alkane. Double the carbon number, leave it. Double the carbon number, leave it. Double the carbon number, leave it. That is alkane. So by watching this formula, one can easily identify that whether given molecule is either alkene or alkane. Is it clear? Now, the formula required for calculating number of sigma bonds are C. Same formula, number of carbons multiplied by 3 minus 1 I am saying. This is a formula to calculate. What we need to calculate? Number of sigma bonds. What is the formula to calculate number of sigma bonds in alkane? What is the formula to calculate number of sigma bonds in alkane? Number of carbons multiplied by 3 plus 1. Now here, number of carbons multiplied by 3 minus 1. If you know this concept, isomerism is easy for you. How to create isomer? Say I am creating many molecules. So what is the common thing present in this one? Is it same molecular formula? Is it have same molecular formula? You know what is molecular formula? What is this? General formula. This is not molecular formula. This is called general formula. This is called molecular formula. You know empirical formula? Empirical formula will be there. In stoichiometry you will learn. There I will explain. No need to confuse. Right now you remember only 2 words. First one is a general formula. It is a family formula. Your surname, your father, your mother and yourself, your sister, brother, all having a same common surname or not? This is that surname. These all are family members. All are family members which are belongs to this general formula. So these all molecules having same general formula, but they don't have same number of carbons, same number of hydrogens. Is this 2 molecule having same number of carbons, same number of hydrogens? Is they have same number of carbons or same number of hydrogens? No, they don't have same number of carbons and hydrogens. But I can say that these 2 are same. In which property they are same? They are belongs to alkene. They carry only one double bond. Suppose I will give this structure C2H4. See this. Carbon, carbon, I am writing a double bond. First you write down double bond. So every carbon gets surrounded by how many hydrogens? Maximum. What is the valency of carbon? Do you know valency? Do you know valency or not? What is the meaning of valency? Valency nothing but how many bond pairs can developed by any central atom by using their outermost free electrons is called valency. So right now you remember carbon valency is 4. That you remember. You can't create more than 4. You can create less than 4, but you can't create more than 4 for which one? Carbon. So carbon never adopts. Carbon never adopts valency more than 4. How many bonds you can write maximum for a carbon? Maximum 4. This point you remember right now. Anywhere if carbon comes, what is the maximum number of bonds around carbon? 4. Now see, already I written 2 bonds for this carbon. Then how many bonds can I create around this carbon? 2. So can I write hydrogen and hydrogen or not? Is it right? Now here also I can write one hydrogen and here one hydrogen. So how many bonds are total? Total how many bonds? Around this carbon how many bonds are there? 4. Here also 4. Now see, when two atoms developing a double bond in which one will be sigma, other will be pi, and between these two only one bond is there or not, that bond becomes what? This bond becomes sigma, 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 sigma. In this how many sigmas are there total? In this how many sigmas are there? 5. 5 or not? Now apply the formula, number of carbons multiply with 3 minus 1. How many carbons are there in this one? 2 carbons. 2 into 3, 6 minus 1, 5. So in this how many sigmas are there? 5 sigmas. Is it clear? Now I will give one more example. Here how many carbons are there? 3 carbons. Write down 3 carbons in a straight way. Anywhere you can put a double bond. I am writing 3 carbons. Carbon, carbon, carbon. Right? So this is alkene. Try to develop a double bond between 2 carbons. Only one particular pi bond is required. So I am putting a double bond either this side or this side. Any side you can put. Suppose if I introduce double bond here. Now balance with hydrogens. Here how many hydrogens are required? Here 2 hydrogens are required to get number 4. Now here how many hydrogens are required? 1 hydrogen to get valency 4. Every time carbon carry how many bonds? 4 bonds. Here carbon carry how many bonds? 1, 2, 3, 4. Here also 1, 2, 3, 4. Now here how many bonds are present? I need to introduce 3 hydrogens. Right? Now how many sigmas? How many sigmas are there in this one? Number of carbons multiply with 3. 3 into 3, 9. 9 minus 1. 9 minus 1, 8. So is it 8 or not? 1, 2, 3, 4, 5, 6, 7, 8. So 8 sigmas are available. That is the answer. Take 2. So what we are calculating? Sigma or pi? Sigma bonds we are calculating. Clear? Written? Now I am going to ask one question. See, in this how many sigma bonds are present? How many sigma bonds are present? See, these 4 we need to substitute here. 4 into 3, 12. 12 minus 1, 11, like that. But you need to confirm that whether it is alkene or alkane. That is the strategy. Suppose here same 4 I am taking. In this how many sigma bonds are present? 13. Is it clear? Now see this. Next possibility, that is alkane. What it means? Alkane means carbon carbon triple bond. Between 2 carbons there is a presence of triple bond. Right? Now general formula is Cn H2n minus 2. See the difference in their formulas. If it is a alkane single bond, CnH2n plus 2, then CnH2n, then CnH2n minus 2. So every time how many hydrogens I am removing? 2 hydrogens I am removing. First what I written? CnH2n plus 2, then CnH2n, then CnH2n minus 2. Means every time I am reducing 2 hydrogens. Every time I am reducing 2 hydrogens in their general formula. Suppose see, if you want to create a triple bond, definitely how many carbons are required? 2 carbons minimum. Suppose if I substitute 2 here, then how many hydrogens you will get? Then give the answer. How many? 2. 2 into 2, 4. 4 minus 2, 2. So can I write C2H2? Then what about C3? C3, 3 into 2. 2 into 3 how much? 6 minus 2, 4. So here it is 4. Double the carbon number minus 2. Double the carbon number minus 2. Suppose C. Here 4 is there. Double the carbon number 8. 8 minus 2, 6. Suppose C8 is there. C8. Double the carbon number 16. Okay. 16 minus 2. How much? 14. Suppose C5 if I take. C5. Double the carbon number 10. 10 minus 2. 8 like that. Now C6. Double the carbon number. 12 minus 2. 10. Now double the carbon number. See, you will get H2 here now. So you will get 12. Like that we can keep on creating a hydrocarbon which carry triple bond. Now formula is there to calculate number of sigma bonds here. Number of sigma bonds is equal to number of carbons multiplied with 3 minus 3. It is a formula to calculate number of sigma bonds. Will you calculate this? See, I am taking 2 carbons only. I am taking only 2 carbons. Then how many hydrogens should I write here? How many hydrogens can I write here? Can I write 1 or more than 1? Only 1. Why? Valency 4, maximum 4 is over. Now here also 1. Is it C2H2 or not? Is this molecule? Now see, I am writing one more. I am writing 3 carbons. And I want to create a triple bond, alkane. So you can put anywhere triple bond between 2 carbons. Suppose if I introduce triple bond here, then balance with hydrogen. This carbon, one triple bond is there. If I write one hydrogen, valency 4 is over. Right? Now this carbon, how many bonds are present already? This carbon already right side 3, left side 1. Already 4 is there. No need to add hydrogen. Here how many bonds are present? 1. Only 1 bond. Can I balance with 3 hydrogen? Why I am adding 3 hydrogens only? Why I am adding 3 hydrogens? So that carbon carry 4 bonds. Now calculate number of sigmas. This is sigma, sigma, and this is sigma. Here how many pi bonds are present between 2 carbon? 2 pi bonds are present. And here how many? Sigma. Here 2 pi bond. Here sigma, 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 sigma. Here total how many sigmas are there? By watching this you can say 3 sigma. Here how many sigmas are there? Is it 6 sigmas or not? So suppose if you apply this formula, in this how many carbons are there? 2 carbons. 2 into 3. 6 minus 3. 3. Now, here 3 carbons are there in this. 3 into 3. 9. 9 minus 3. 6. Means once if you know how to create a hydrocarbon of family with carbons and hydrogens, okay, and if you know how to write a molecular formula based on their valencies, based on substituting suitable hydrogens to attain tetravalency of carbon, one can easily identify number of sigma bonds. Suppose one example I will give, just say the answer. Suppose if I am giving C5H8, how many sigma bonds are present in this alkyne? How many sigma bonds are present? See, right, if I give like this you can identify, but in your examination they won't give like this, they will give like this. C5H8. How can you confirm that it is a triple bond? First you need to confirm a triple bond or not. How can you confirm? You can confirm triple bond by observing the carbon number. If you double the carbon number, alkene. If you double the carbon number, -2, alkyne. Alkyne means this one. If you double the carbon number +2, alkane. Is it carbon number double? Yes. And -2. So is it a triple bond or double bond? Triple bond. So then what is the formula? Number of carbons multiplied with 3 minus 3. So how many sigmas you will get? So here 5 into 3, 15. 15 minus 3, 12. So this molecule carry 12 sigma bonds. Like that. Is it clear? Take it. So I will give an example. By watching that molecule, you need to identify how many sigmas are present in that molecule, right? Now see this and say the answer. So I am taking C4H8. How many sigma bonds are present? You need to decide which formula should be applicable. I am not going to reveal it is a alkane, alkene or alkyne. It may be single bond, double bond or triple bond. You need to confirm. Then you need to choose a suitable formula. Is it alkane, alkene or alkyne? Alkene. Why? Number of carbons, if you double, you will get same number of hydrogens. So it is a alkene. How many sigma bonds? How many sigma bonds are present in this one? 7. Why? Number of carbons multiplied with 3. How many carbons are there? What is alkene formula? What is alkene formula? Number of carbons multiplied with 3 minus 1. Is it alkene or not? So, if you want to select this one, 4 into 3, 12. 12 minus 1. How many sigmas? 11 sigma. Like that, they will give option. 4 options they will give. Okay? So, they may give 13 sigma, 11 sigma, 9 sigma. So that alkane, alkene, alkene will come. 4 options they will give. You need to confirm whether it is alkane or alkyne. Now see this. You need to give the answer for this. See C7H12. How many sigmas are present in this one? Guess. They will give like this. The number of sigma bonds present in this following molecule. Like that they will give. How many? So is it a alkane, alkene or alkyne? Alkyne. What is the formula? Number of carbons multiplied with 3 minus 3. So 7 into 3. How much? 21. 21 minus 3. 18. So can I say 18 sigma? Yes. That is the answer. Is it right? Now. So C8H18. How many sigmas are present? C8H18. Are you able to understand? Formulas. Do you know the formula? Just now given. If you apply that formula in a suitable way, 100% without any hesitation, without any mistake, you can predict the answer. That is a strategy. Thing is, you need to identify the formula clearly. Without identifying formula, it is impossible to attempt these questions. So make sure, definitely you should be familiar with formulas. Wherever formulas comes, that you need to prepare a short notes over there. I will give that formulas even. But if you remember that formula, suddenly if any question comes, you are in a position to use that formula to calculate suitable numbers. Now, is it a alkane, alkene or alkyne? Alkane. So, what is the formula for alkane? Number of carbons multiplied with 3 plus 1. So, how many carbons are there? 25. So, 24 plus 1, how much? 25 sigmas. Is it right? So, I will give one more, just say the answer. C9H16. First you confirm whether it is alkane, alkene, alkyne. If you conclude that one, then it will be easy for you. What is it? Triple bond. If you are confusing, say double bond, triple bond or single bond. So this formula belongs to which one? Single bond, double bond or triple bond? Triple bond. So what is the formula to calculate number of sigmas? Number of carbons multiplied with 3 minus 3. How many carbons are there? 9 carbons. 9 into 3. 9 into 3. 9 into 3, 36. 9 3 jar. 9 3 jar? Do you know 9 table? I'm not asking 10 table, I'm asking 9 table. 9 3s are 27. 27 minus 3 or not? 27 minus 3 how much? Is it 24 sigmas or not? Yes. Clear? Take it. So like that they will give one formula. Find the number of sigma bonds involved in this alkane. Find the number of sigma bonds involved in this alkane. Like that they will mention alkane and they will give formula. Okay? And they will ask which among the following is a alkane? Which among the following is a alkene? Like that they will ask. Clear? See. Right. The number of sigma bonds present in C6H12 is, okay, option A, that is 19 sigmas, 17 sigmas, 15 sigmas, option D, 14 sigmas. Like that they will ask. How many number of sigma bonds present in C6H12? How many are present? Is it a double bond or triple bond? Double bond. Double bond means it is alkene. Number of carbons multiply with 3. Minus 1 or not? 6 into 3. 18 minus 1. 18 minus 1 is 17 sigma. Like. Means by watching this one can confirm that whether it is a single bond or double bond or triple bond. Based on the formula one can confirm. So without knowing this it is impossible to attempt. Right? One has to know, by using this formula you need to conclude that whether it is single bond or double bond. Okay, next one is C. Here calculation of pi bond. How to calculate pi bonds? Now your formula is there. If you want to calculate number of pi bonds is equal to 2n1 plus 2 minus n2 by 2. This is a formula to calculate number of pi bonds. Here what is n1? n1 indicates number of carbons n1 indicates number of carbons, n2 indicates what? Number of hydrogens. n1 indicates number of carbons, n2 indicates number of hydrogens. So I will give one molecular formula. In that formula you need to calculate how many pi bonds are present. Right? What is pi bond? Sidewise overlap is pi bond. Head on overlap is sigma bond. Which is strongest bond? Sigma bond is stronger than pi bond. Right? This is called sigma bond. And this overlap is called pi bond. Side on overlap, lateral overlap is pi bond. Head on overlap is called sigma bond. Okay? Now see this. I am going to give one formula. Just try to identify how many pi bonds are present in that one. So C2H4. Now apply this formula. How many carbons are present? 2. How many hydrogens? 4. So substitute in this formula. So total number of carbons are 2. 2n1 plus 2 minus n2 how much? 4 by 2. Then how much you will get? How much you will get? 4 plus 2, 6 minus 4. 4, 2 by 2. 2 by 2 means what? 2 by 2 means you will get 1. What is 1 indicates? Only one pi bond. Only one pi bond means first you should write like this. Carbon, carbon, first you write down one double bond. Here you write down hydrogen, hydrogen, and here hydrogen, hydrogen. This is sigma and this is pi. sigma, 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 sigma. In this molecule, how many pi bonds are present? Only one. Only one pi bond. So that's why answer is 1. Is it clear? How many pi bonds? 2 pi bonds. Will you calculate this? 2n1, 2 into 3 plus by 2. 2 into n1 plus 2 minus n2 by 2. 2 into 3, 6 plus 2, 8 minus 4 by 2. 8 minus 4 means 4 by 2. 4 by 2 means how much you will get? 2. 2 pi bond. First write down 3 carbons here. Carbon, carbon, carbon. Then create 2 pi bonds here. Now here, if already 3 bonds are there, put 1 hydrogen, and here put 3 hydrogens here. 1 hydrogen, 1 hydrogen, and here 1 more hydrogen. Okay? Here how many sigma bonds are there? 1 sigma. Here remaining 2 are how many pi? 2 pi. Clear? Now we can also consider one more structure. Carbon, carbon, carbon I given. Now here I am putting one double bond, and here also I am putting one more double bond. Like that also we can write. Here how many hydrogens should I write? 2 hydrogens. Here 1 hydrogen, and here 1 hydrogen. Here how many hydrogens? No hydrogen. And here 2 hydrogens. So put 1 hydrogen here, put 1 more hydrogen here. Sigma, 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 sigma. Here what is this? Pi bond. And what is this? Pi bond. Here how many pi bonds are present? 2. Here how many pi bonds are present? 2. Means you can calculate number of pi bonds for a dissimilar molecule with same number of carbons and same number of hydrogens. Is these 2 molecules are same? No. It is a alkene. It is a alkyne triple bond. But what is this? Alka-diene. Diene. 2 double bonds are there or not? In this molecule, how many double bonds are there? 2 double bonds. In this, how many double bonds are there? In this, how many double bonds are there? In this molecule? No double bond. Here only triple bond is there. Triple bond and single bond. In this, how many double bonds are there? 2 double bond. So now this kind of isomers are called functional isomers. See, if you know how to calculate sigma and pi bonds, isomerism is very easy for you. This is a alkyne, and what is this? Alka-diene. Alkyne, alka-diene are functional isomers. Now these 2 isomers are called functional isomers. Is it clear? Is it right? Now I will give one molecule. Just say its structure. C6H6. You need to work out in class. How much you will get? 4 or 5? Why? You need to substitute in this formula. In this, how many carbons are there? 6 carbons. 2 into N1, 6. What is N2? hydrogens. In this N1 is carbon, N2 is hydrogen. N1 is how much? 6. 2 into 6 how much? 12. 12 plus 2? 14. 14 minus 6. Here hydrogens are 6 or not? 14 minus 6. 14 minus 6 is what? 8. 8 by 2? 4. Now in this molecule carry how many pi? 4 pi. Okay. So if you want to create this, a structure, it should carry how many carbons? 6 carbons. See, you need to write like this. 1, 2, 3, 4, 5, 6. How many carbons are given? 6 carbons or not? Here how many pi bonds I want to create? 4 pi bond. Now here you write one triple bond, and in middle you write one more triple bond. Better you write here. You can write like this. 1, 2, 3, 4, 5, 6. Right? Now here you write one triple bond, and here you write one triple bond. Here how many hydrogens should I write? One hydrogen. Here also one hydrogen. Then see, here one hydrogen, and here one hydrogen. Here one hydrogen, one hydrogen. Is it balanced? All carbons are balanced or not? Now all carbons are balanced. 1, 2, 3, 4, 5, 6. 6 carbons are balanced. Now 1, 2, 3, 4, 5, 6. It is balanced. And here how many pi? One triple bond carry how many pi bonds? 2 pi bond. And here also one triple bond carry 2 pi bonds. That is the answer. So 2 pi means 4 pi. It is not benzene. C6H6 is not benzene every time. C6H6 is a molecular formula. That molecular formula maybe belongs to many molecules. So generally you people are very familiar that if anybody says C6H6 means you will think it is benzene. It is not benzene. See, if I say benzene, it will give same formula, but pi bonds will not match. Here how many pi bonds? 1 pi by pi, pi. But how much you are getting? 4 pi. Is it benzene? No. But formula is remain same. So what I would like to say is, these formulas applicable only for open chain, not for rings. Don't create any ring if I use this formula for calculating number of pi bonds. Is it clear? So C6H6 is not benzene right now, but C6H6 is a general formula which helps to identify variable set of molecules which carry same molecular formula. With respect to this formula, I can create many molecules which carry same C6H6. Is it clear? So that is end of calculating sigma and pi bonds in a given organic molecule. Okay. So in your next session, we will see some other concepts which are helps to calculate number of lone pair. Okay, and how to determine hybridization by knowing number of lone pairs and number of pi bonds as well as sigma bonds. You people are very familiar with that lone pair calculation and sigma bond calculation. After that, one can easily identify hybridization of a given molecule. Okay, so we'll stop here. We'll continue in your next class. So don't miss these basics. Basics are most important for your each and every concept which are there in your syllabus. So but these basics, straightforward questions are very rare. Straightforward questions are very rare, but they may helpful to understand the concepts clearly. If you want to understand any concept clearly, you should be very strong in basics. So with the help of basics only, that concept related questions will be coming in your exam. And if you understand that question, then you can attempt the complete answer very easily out of that 4 options. So without any basics in your chemistry, it is impossible to attempt NEET questions. Starting basics, I am going to teach you about how to calculate hybridization, how to calculate structure, how to calculate sigma bonds, pi bonds, degree of unsaturation, okay, then linearity, planarity with hybridization, etc. Okay, so we'll stop here, we'll continue tomorrow.